Hey, how's it going, guys? Let's get going with this introduction to logarithms classwork. So this first one, it does say for maximum understanding, attempt without a calculator. So you are allowed to use a calculator for these problems, but I do recommend trying them without it for the first time. So in order to do it without a calculator, a couple ways to do it. I'll explain a few ways. The first way is to make it equal to x at the start and to use that log loop that we originally talked about. So we're going to say 2 to the power of x is 2, or in other words, 2 to the power of x is 2. And it should be nice and clear that the only way that this equation could be true is if x is equal to 1. And that is going to be our correct answer, because only the number to the first power will give you the same answer back. An alternative way of thinking about a question like this is saying 2 to what power is 2, so you write it out. This one you can just say maybe an English version of it. So you could say 2 to what power is 32. To answer a question like that, you either have to have it memorized, or maybe you could do like 2 times 2 multiple times itself. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So you did that 5 times to get there. You could also remember from our list that 2 to the 5th power is 32, and that will give you 5. However, in the event that these methods are not working for you, you are allowed to simply use a calculator. So to use a calculator for it, don't need calculus on there. To use a calculator for these questions, you're going to go ahead, a couple different options. I'll show you different ways. My favorite way is to use alpha, window, and then the number 5 will give you log base. So you see the number 5 there. If you hit 5 on the calculator, this guy will show up right there, and you can type it in as it appears. Nice and easy. Can't see the answer there, but the answer is 1, because 3 to the first power is 1. So you kind of just got to pick your favorite method for questions of this nature. Pick your favorite. We got log base 525 of 125. That's going to be 5 to the third power is going to give you 125. So again, hopefully get it without a calculator. With a calculator, no big deal. Because starting on questions like number 5, you have no choice but to use a calculator. So on questions, you have no choice. So again, the previous buttons I showed you before were alpha, window, enter. For this particular problem now, we have another method that I showed, which was math, scrolling up to log base and hitting enter, and the same exact thing. We can just plug it in nice and neat. So there's a 2 there, 3.58. And that'll give you this 1.83995, which will round to approximately 1.840. And we're doing the same exact thing for each one of these problems. So again, that alpha window and that number 5 for the log base, 3.83, and that's going to give us 0.834. 4 I don't know, 4 decimal places, 3 decimal places. It's not really all that important. It looks like answer key is giving us 3 decimal places, so 3 or 4, either way is cool with me. So this one you might be confused because it has that ln, but that is actually just a straight button on the calculator. Remember, that means log base e. The button on the calculator is down here next to the 4, so we just hit the ln button. And once you have the ln, you just go 4.6, boom, gives you that 1.526 answer. So approximately 1.526, 3 decimal places. And again, log base 4, alpha window 5, log base 4 of 22. Oh, not log base 422. And this one is 2.2297 or 2.230 is another good option for that one. Any of these, good to go. All right, so we don't need the calculator for the next couple. We've practiced the calculator enough. Now these are just simply rewriting, making sure that you understand your log loop. So again, these are great questions to practice on your own before you watch it. But for this one, our log loop says we start off at that number 9, we raise it to that second power, and it equals 81, or in other words, 9 squared is 81. And the process of rewriting it is going to be very important for some of these future questions. we have a to the 5th equals b for this question. And 361 to the negative 1/2 power is 1 over 19. By the way, if you are somebody who's interested into why this is true, if you want to know why it's true, the negative 1/2 part, so anytime you have a negative exponent, it means a positive exponent on the bottom, and a 1/2 exponent, as a reminder from a previous lesson, that's the same thing as the square root. So the square root of 361 is 19. Just a cute little explanation there for you. Rewrite each equation in logarithmic form. So same idea, but backwards. So again, the log loop starting at the 2, going to the 16, coming back to the 4. Log base 2 of 16 equals 4. Same ideas here. Log base a of b is negative 19. Notice the exponent's always on the right. And here, log base 15 of 1 is 0. And that's going to be an important concept going forward, that anything to the 0 power is 1. So log base anything of 1 is 0. Very common idea. So solve each equation, give both an exact answer and an approximate answer. So now we actually have to solve equations. So we're trying to get that r alone. So we're going to use our log loop first. So we have log base 11 of 67 equals r. And when you're doing that, so just cute little thing, 1167r coming around like that. And this is actually our exact answers. This is one of the answers that I'm looking for. The other answer is going to be plugging it into the calculator. So we take our calculator, and again, with the alpha window and the number 5, 1167, 1.753. And again, that's approximately, so I use little wavy arrows for that one, or wavy equal sign, sorry, for that one, because it is approximate. Continuing on with number 16. So number 16, same idea. We have log base 10 of 47 is equal to a minus 7. And then algebra type problem, we have to add 7 to both sides. Be very, very careful. You're adding 7 not to the 47, but to the side of it. So now we have log base 10 of 47 plus 7 is equal to a. And again, this is our exact answer. And now we have to type into our calculator for the approximate answer. Quick reminder for yourself, in the event that you have a 10 here, you actually don't need to write the base. So it would be even more correct, and honestly better, to not even write that in, because that's how it will be in future classes. So this is actually a better way of writing the answer here. It's not wrong to write this. It's still correct. I'll give you points for it. But this is the better answer there. And on our calculator, we can just hit the log button right here next to the number 7. And log of 47 plus 7 on the outside there. Turns out that's 8.672. There we go. Finishing it off, that was our first page. Let's go to the next page. So our next page here, number 17. So this one, we have that e. So when we rewrite with log base e, we'll have log base e of 47 is equal to 5x minus 4. However, when we write the log base e, we don't want to write that much. We're mathematicians being lazy. We're going to rewrite that as an ln instead. Go to that next step, but we do have to add 4 to both sides. So plus 4 is equal to 5x. Divide both sides by 5. ln of 47 plus 4, all divided by 5, is equal to x. Here's our exact answer. And for our approximate answer, we just got to go and alpha y equal enter. And ln of 47 plus 4 divide by 5, and we get 1.570. And there we go. Number 18 is slightly different. If you're watching this video on Tuesday night or maybe Wednesday night for your Thursday classes, you haven't done questions like this, but in order to get it into our log form, we have to have this 10 alone. We can't have that 7 there. So our very first step here is to divide both sides by 7. And we're going to cancel out those 7s here. So we're going to have 10 to the power x is 54 divided by 7. This time when I do that log loop, I'm specifically leaving that 10 out. Remember, it's invisible. You do not need it. So log base 10 of 54 over 7 equals x. This is our exact answer. And our approximate answer, plugging into the calculator, we got log 54 divided by 7, and 0.887 is the correct answer. And there you go. Moving on to number 19. So number 19, same exact idea. We need that 10 to the power on its own. So we're going to go ahead and add 9 to both sides. Now we have 10 to the n minus 8 is equal to 4. Log loop. Log, we don't need to write the base because it's a 10, is equal to n minus 8. Now we add 8 to both sides. I'm not going to write the plus 8 on both sides for this one. Plugging it into our calculator, we got log of 4 plus 8, 8.602. Continuing on, number 20. So number 20, you have two different things. Not only you have the division and the subtraction, but here we have the division and the addition there. So we have to subtract both sides, minus 7 on both sides. 6 times 17 to the n equals 6. Then we have to divide both sides by 6. And it turns out they cancel here as well, and you just get 1. And then log loop, log base 17 of 1 is n. But this one, the exact answer and the approximate answer are the same because just like that previous question, log base anything of 1 is exactly 0. Anything of 0 power is 1, and therefore log base anything of 1 is 0. Here we go on the next one. So we're going to subtract 6 on both sides. We're going to divide both sides by negative 2. And then we're going to use our log loop. And divide both sides by 5. I'm going to write my answer up here. X is exactly equal to log base 2 of 85 over 2, all divided by negative 5. So X is approximately, really crazy looking answer here. So alpha window, oh my gosh. So we hit alpha window of base 2, 85 divided by 2, divided by negative 5. And I got, when I did it, negative 1.082. That'll be 3 decimal places. And there we go. There are 2 answers. A little bit of a crazy question. And the last question here is going to be the craziest of all. Lots and lots of steps. We got to add 6 to both sides here. Divide both sides by 4. When you do that division by 4, it is going to be a whole number. It turns out that guy is 18. Then our log loop, log base 6 of 18 is 9 minus p. Cute little trick for you to memorize if you'd like to memorize it. But whenever you're subtracting a letter like this, if you just move it to the other side, it's positive. If you move this to the other side, you'll get the final answer. So p is 9 minus log base 6 of 18. So if you notice, I just kind of like switch the positions of those two. That's always going to work on questions like this. So again, there's your exact answer and your approximate answer using the calculator. Is 7.387. And there you go. We have finished all of the exponential questions, and now we have our logarithmic questions. So again, some of these questions I have not quite gone over yet in class, but we will be going over them by Thursday. Here we go. Why am I closing my calculator? We still have calculator stuff to do soon, I'm sure. All right. So a question like this, please note the computer and honestly a lot of textbooks and professors in the future will not put the parentheses when it's just a single number or a single term. I personally enjoy just putting those parentheses in. So I'm going to go through and like put parentheses in on every single one of these questions that might require it. So there you go. We got some extra parentheses there. I think those are all the extra parentheses we need. Because we have a log on both sides, and when everything is in a log on both sides, we can actually just pretty much just cancel them out. So we got m plus 4m plus 2 equals 18. We're going to subtract 2 on both sides. Pretty basic stuff there. Divide both sides by 4. All right, kind of a freebie. On this one over here, same thing. The log 6's basically cancel out because we have the same exact one on both sides. Now we have to solve this equation. This one has a little bit of review because we're moving the k and the 2 over. So k squared, we're subtracting 3k to get plus 1k minus 2 equals 0. So we move that 3k over, move that 2 over, and now we have to factor. Multiplying to -2 and adding up to +1 is k plus 2 and k minus 1. So we got k is equal to -2 and +1. However, there's a big rule that we have not quite gone over in class yet, if you're watching this early, but you cannot have negative arguments for a logarithm. So what that means is if I plug in -2 into either of these two original equations, if I plug in -2 there, like this will be 2 plus 3 times -2, and that's going to be -4. You can't have a negative on the inside of a log. It will always give you an error. Like if I just typed in here like log of -3, for instance, it's just going to spit out non-real answer. So definitely going to be an error. Technically, there are imaginary numbers that work out that way. It actually is the same imaginary number as the square root of -1, which is crazy results. But we have to cross this guy out. That is not part of our answer. So we have only +1 as our answer. Here we go. After this, so we have log of x is -1. Rearranging this question, anything, so we have on this one, 10 is the invisible base. So we have 10 to the -1 is equal to x. 10 to the -1 is 1/10. You could have also used a decimal number of 0.1. Any of those is correct. And it says if needed, give an exact in decimal. This one is, both of those are correct. They're both exact. The next one, same idea. We're using our log loop. 12 to the third is the inside here. 12 to the third equals x plus 6. I do not have 12 to the third memorized. 144 times 12. Nope, don't have it memorized. 12 to the third power. I'm just using my calculator, you know, just plugging it in. You get 1,728 is x plus 6. Subtract 6 on both sides. We get 1,722 is equal to x. And there we go. Number 27 is very similar. We're going to start by adding 4 on both sides. And now I'm going to try to like really get that understanding here. We have a 1 here. If there's a 1 over here, these numbers are identical. So like going back to that first page, on the very first page, we had log base 2 of 2, we got a 1. Log base 3 of 3, we got a 1. So because this is a 1 right here, b is guaranteed to be 9. Done. Nice and easy. Number 28. So we don't have the logarithm alone, just like this one where we had to add 4. This one we have to divide by -8. 0 divided by -8 is still 0, so log base 9 of x minus 1 equals 0. Going back to our rewriting, 9 to the 0 is x minus 1. Remember, anything in 0 power is 1 is equal to x minus 1. Add 1 to both sides, and we get x is equal to 2. We're almost done. We're at problem 28. We only have, looks like 5 more to go. Here we go. We're finishing up. Now the questions do get a little bit more tough, but it's not end of the world. So we'll start off by putting those parentheses in everywhere where I feel like they are needed. You don't necessarily have to do this, but I like doing it. Just those two. And now we're going to go ahead and add 7 to both sides. So we're trying to, get the logarithm by itself. So we got -4 log 8 7n is -12. Divide both sides by -4. And we get log base 8 of 7n is 3. And then we got 8 to the third power is 7n. 8 to the third power, I probably had that memorized at one point in my life. What is it going to be? 512, I hope? I'm going to double check. I have wavering faith in myself. It was 512. Okay. So we have, I'm going to rewrite it over here because I'm running out of room. We got 512 is equal to 7n, and then we have to divide both sides by 7. 512 over 7 is our exact answer, and if we wanted an approximate answer, we can get that on our calculator. Turns out that is 73.143 is approximately equal to n. Let's keep it moving. So 3, we've got to subtract 3 on both sides first, so be careful in questions like this, because a lot of students want to do like -3 minus 5 and get -2 first. You don't want to do that. This is multiplication here, and this is like adding 3, so we got to be very, very careful to make sure we subtract first. So -5 times log of n is equal to 10. Divide both sides now by -5, and we get log of n is equal to -2. So again, invisible base of 10, so 10 to the -2 is equal to n, which is 1 over 100, or 0.01. Continuing on, and again, you can use a calculator for that 10 to the -2 if you'd like to, but the idea is powers of 10, you just add those zeros with a negative exponent, makes it a fraction. Totally doable. So we have 4 to the -1 is equal to 8m plus 4 here, just still with that log loop. 4 to the -1 is a fourth. So there we go, that fourth. Now we got to solve this equation. I personally recommend getting rid of fractions immediately because fractions are not fun. So we're going to multiply everything by 4, just get no more fractions at all. 1. 4 times 1/4 is 1. This is 32m plus 16. Now we have to subtract 16 on both sides. We get -15 is equal to 32m. And then divide both sides by 32. We get -15 over 32 is equal to m. And we can approximate this in our calculator if we felt like it. -15 divided by 32 is -0.469 if you round it. Continuing on to number 32, same concepts, add 1 to both sides. Log base 4 of -7a plus 7 minus 1 is equal to, why did I write the -1 again? My brain failed right at the end there. I just added 1 to both sides. These cancel out. Don't know what happened there. So we get the 3, 2 plus 1, 3. 4 to the third power is -7a plus 7, so 64. -7a plus 7, subtract 7 on both sides. We're going faster and faster towards the end here. -7a, divide both sides by -7. Holy moly, 57 over -7 is a, and therefore, so we have approximate answer as well. We got -8.143. For our very final problem, we're going to add 4 to both sides first. 5 log base 2 of 9n plus 8 equals -10. Divide both sides by 5. And we got log base 2 of 9n plus 8 is equal to -2. We have 2 to the -2 is equal to 9n plus 8. 2 to the -2, that's the same thing as 1/4 9n plus 8. Again, multiply everything by 4. Get rid of those fractions. 1 is equal to 36n plus 32. Subtract 32 on both sides. -31 is 36n. Divide both sides by 36. N is equal to -31 over 36. Give an approximate answer as well. -31 divided by 36 is going to be negative 0.861 repeating. There you go. Actually, not even approximate, it's exactly equal to, but we are all done. Have a wonderful rest of your day and peace out.